Howdy. Today we're going to look at WIM again and look at something called SSD tables, which stand for Stage Storage Discharge Tables. Now these can be the most powerful, but also most confusing and tricky and frustrating parts of WIM. So I'm going to walk you through how to do a simple SSD table for an infiltration trench. Let's jump right in.
First thing I'm going to do is pick a precipitation point on my map. Next, what I'm going to do, I'm going to go over to my schematic, and typically you need to put in a pre-developed condition and a mitigated condition. However, because we're not really going to be comparing pre to post, we don't really need to do a pre-developed condition. If you're doing 100% infiltration on your site, you could just do the mitigated scenario. So basin, put in a basin, call this basin 1, that's fine. Now I'm going to put in 5 acres of AB lawn, which is a pretty pervious lawn with decent infiltration. And I'm going to put in 5 acres of roads. So I should get very little runoff from this one, but I will get a decent amount of runoff from my impervious road. Next, what I'm going to do is I'm going to add an SSD table by clicking on it and dragging on it. I'm going to right click, connect element to SSD table. And typically I just leave surface flow and interflow. I don't typically mess with groundwater. This rarely will affect your model. If you are dealing with groundwater, you might consider checking that box. Here is the SSD table. Now, what is an SSD table? Well, SSD table is another element in WIM that is highly customizable, allows you to pick how much volume you are going to hold and how you're going to release it. Now let's compare this to a normal detention facility. I'm going to add this in here. A trapezoidal pond. Now, if I click on Quick Pond, you can actually see it's generating, based on these inputs, a table that's going to give us stage, area, storage, discharge, and infiltration. And that's typically what you would do for an SSD table. You're going to manually enter these values. So you might say, well, why would I want to do that? That doesn't make any sense. Well, if I add in infiltration into this pond, say I add in 20 inches per hour with a factor of safety of 0.25. Now, when I open this up, I'm left with this infiltration facility. Now, you will notice that the infiltration is always the same, no matter what your depth of water is. Now, is that actually accurate? Say I have a pond or a infiltration trench. Now, when there is very little water in that infiltration trench, water is really just going to come out the bottom. There's going to be a pretty negligible amount coming out the sides. However, if I am going to be putting in a infiltration trench that has a decent amount of water, say the water level is now up to here, water is definitely going to be coming out the bottom and possibly at a faster rate because there's quite a bit of head pushing that water out. But water is also going to be coming out the sides. Now, WIM doesn't currently capture this with this model. What you might be saying is, well, what if I use this checkbox here? Use wetted surface area, sidewalls. Doesn't that capture what I want? And the answer is no, it actually doesn't. You might be thinking, well, then what does that even do? All right, well, I'll show you what that does. And it doesn't actually do what you probably think it does. So imagine I have a pond that looks kind of more like your typical pond. As water builds up in this pond, water will come out the bottom in WIM, but it will also come out the sides. But what they do to calculate the water coming out the sides is they just calculate the vertical component. So if you have this kind of steep slope that I'm looking at, it's not going to figure out water going out laterally. It's just going to figure out water going out vertically. So say I had 0 side slopes for this, and this is a good way to figure this out. If I put 0 side slopes in here, theoretically I have water coming out the side walls. If I hit this open again, you can see that infiltration rate is still the same for every single depth, which again doesn't make sense. I thought it was coming out the sidewalls. Well, it's just coming out the vertical component. And if you can see from these drawings that if I have no slope here, then there is no vertical component of that wall. It only comes out horizontally. It's only when we add in those 3-to-1 slopes that we're going to be getting water coming out the sidewalls. Now you can see it is starting to increase. Now, when we do an infiltration trench, typically we are going to be building this in with vertical sidewalls. So we want to capture, or I should say, we are allowed to capture that water coming out the sidewalls. So let's look at how to do this in an SSD table. And that is the way you could theoretically do this. Well, this is actually a pond, so let's open up an infiltration trench. The first thing I want to do is I want to try to create this exact same situation with my SSD table. Could I just copy this over and copy this in? Yeah, you really actually could. This is not the easiest information to copy over, but there's a way to do it. So what I'm going to do is I'm actually going to generate these values in Excel. And I am just going to go with these same values here, 200, 5, 4 for my effective total depth. I'm going to have a top and bottom slope 0.01. I'm going to make these side slopes 0, which is more typical for an infiltration trench. I'm going to make this layer 1. I'm going to make this 4. I'm going to use 0.33 is fine. Actually, I can go up to 0.4, so I'll do that. I'm going to delete these other ones. I'm going to create some infiltration for this. I like that 20 inches per hour value. I'm going to put in 0.25. Again, this isn't going to do anything. I can turn it on, but because I don't have any sidewall slopes here, it's not going to affect any values. Now I'm going to come over here to my outlet structure data, and I'm actually going to change this to a flat structure. So at 3.5 feet, water is going to come out the top of this. I'm going to set my riser diameter to 24, set my riser diameter to 18. I don't actually want an orifice in the bottom here. Okay, let's see what the values I came up with now. Here we go. Stage, area, storage, discharge, infiltration. And you can see as I get to that 3.5 feet, I'm starting to get some discharge coming out. Now, I don't actually know if this is going to be a big enough trench, but I'm just going to try it and see how it goes. So first, I'm going to jump into Excel, and I am going to try and recreate this exact SSD table. And then I'm going to be able to manipulate it. I'm going to add these 5 categories here. Stage. Now, I don't actually need to put in every single one of these values. I really just need to pick an increment that I can go off of. So I'm just going to go off of 1/2 foot increments here. 0, 0.5. It's actually really important that you put 0 in here for your value. So area. What kind of area am I talking about here? Well, as you can see, the area is the exact same for each one. So I'm just going to create a little cell down here. Width, length, we have 200. Width, we have 5. An area I'm going to put over here equals 205. Now, don't forget that WIM loves using the value of acres, so I'm going to come in here and I'm going to make sure I turn this into acres. You can see I came up with the same value here, 0.022 acres. The next thing I am going to come up with, I can literally come in here, put this in, so now I've got my area set up. Now with storage, all I need to do is copy area times stage. That's what volume is. Your surface area times your height. So if you can imagine this in 3 dimensions here, if we look at our surface area as being this bottom piece, you multiply that by however high you are up, that is going to give you, for example, if we're coming in here, now at 0.5 feet, we now have a volume of 0.5 times our bottom surface area. So at 0 stage, we're going to have 0 volume, and this is going to be in acres. Discharge is going to be in CFS. Filtration is also going to be in CFS. So by hitting Control-Shift-1, I can actually make this a smaller number. And in reality, I really want to make this have a few decimal places because, as you can see in WIM, we've got a few decimal places. So next, let's come in and do our discharge. Now, what discharge are we working with? Well, at 3.5 feet, we know that there is a riser. Now, I don't really need to calculate this. I could figure out if I wanted to by using the orifice equation, but really what I want is I want to have water coming out of the top at a certain infiltration. And I'm hoping that it's never going to get to this point because I want to infiltrate all of my stormwater, right? So I'm actually going to just make this 10, which is a huge amount of water, right? How are you going to get that amount of water? Well, I'm really just trying to figure out, is water coming out of this riser or not. And if it is, I need to redo my infiltration trench anyways, so it doesn't really matter. This needs to be big enough that the model is not going to crash. And if I really wanted to, I could probably add in some really big values here as well. Because again, what I really don't want to do is I don't want this model to crash. So if I make this really large, as water builds up in my infiltration trench, so say water starts coming out, and maybe I can make this a different color, at a really, really fast rate coming out, let's call this onto the pavement or wherever. Once it hits that point, that means my infiltration trench is not big enough. Next, what I want to do is I want to come in and I want to make some infiltration. Now, what's the infiltration rate that we had? 20. This is in inches per hour. And factor of safety of 0.25 or factor of safety of 4. I'll call this 4. I need to figure out what my infiltration rate is in CFS coming out of this. So how do I do that? Well, if I know what my surface area is, I can figure out what it is coming out the bottom. And before I do that, I actually need to convert this inches per hour into feet per second. So I'm going to cheat here, inches per hour to feet per second. And it's a very small number. So instead of doing that, I'm going to do feet per second to inches per hour. 4320. So I'm going to say this divided by 4320. Really small amount of feet per second. And then I also need to include my factor of safety. So this is going to get even smaller, really small value. So you can see the amount of surface area, increasing that is going to massively or have a significant increase in the infiltration rate. So what I'm going to try first is equals this times this divided by 4. I need to hit some dollar signs in here. I'm hitting F4 to do this, by the way. And let's see how this compares to what I came up with in my WHM value. Let's see, so I have quite a bit higher number in WHM. I'm curious what I did differently. Inches per hour into feet per second. Well, you know what it is? It's because I have this in acres. So instead of doing, I'll turn this into square feet here, equals here. Should give me the right value. Okay, 0.0115, and I think you actually have to have 0 in for this first value. So here we go. Came up with the same values. So that is just water coming out the bottom. Now, how do we account for these sidewalls? Well, we also know that there is water with a length and a width. If we know the width and the height, we can figure out how much is coming out each wall. So let's figure out what the surface area is coming out those sidewalls. So if I go back to this drawing, this is my length, this is my length, this is my width, and this is my height. I know that is going to equal length times height, and height is the depth of water. So since I already have my stage here, I can do that. Length times, and by L I mean length times height, which should be 0 for that one. And I actually have this side, but I also have this side over here. So I'm going to multiply this by 2. And that should give me just the length times, so that should give me this wall and this wall over here. Now we also need these back 2 walls. Do that in a different color here. This wall and this wall. Getting a lot of color on this drawing. So I'm going to come in here and I am going to also multiply that by, add that to the width, because there's 2 of those walls. My formula here. See, it didn't really increase very much, 200 to 205. And the reason is this width is pretty small. It looks really what I'm drawing here, and really what I drew is something with a long trench. So the length to width ratio is very large. The length has a much bigger effect than does the width. So now, just come in here, and let's, instead of doing this times that square footage, let's do it times this plus. You can see we've gone from 0.115 to, as we get up to these higher values, we are, almost double the infiltration capacity. So this makes a big, big difference. And the really nice thing about doing this in the chart is if I say, well, I did some more testing and I figured out I actually have 40 inches per hour, I now can just change it right here. Or, oh, I need a bigger trench. I'm going to make this 500. I'm going to make this 8 feet wide. Automatically change our values. Okay, let's figure out how to actually throw this into WIM. Now, a couple things you need to do. This stage computed can be the most annoying thing to try to figure out. So I just uncheck this. I'm going to click in manual infiltration. I don't know if this actually matters. It seems to work with it on or off. Evaporation, you shouldn't have any because this is an underground trench. Precipitation, again, you shouldn't have any. This is an underground trench. I need to check on these couple and hit manual. And I can either hit infiltration or manual here. It doesn't really matter. I usually hit infiltration because it then let's actually see what happens. Not sure why this is called infiltration versus manual. I don't think it actually matters. There's two different ways you can bring this in. I can create a text file or an Excel file, copy this information into there, or what I actually typically prefer to do is I just copy and paste this data in. Copy and paste. And voila. Now, I would not be surprised if this model fails. This is not a very big trench, and there's 5 acres of impervious, but let's just see what happens. You can see I got 86% infiltrated. So let's increase our trench by, increase it by a significant amount. You see what I did? I literally just took this over and I went to this first cell and I copied it right over. And it's always good to make sure that these values look like these values. So I had 86% infiltrated. Somehow now I have 65% infiltrated. And you know what? It's because I made this trench smaller instead of making it bigger, which makes sense. Okay, let's see what I get this time. Okay, I got 99.97%. Technically, you need to get 100%, so I might need to do some more work here. There's different ways I could do that. I could make this deeper, and by doing that, I could, maybe make only this last foot have a outflow. I could increase the infiltration rate if I'm able to do that, potentially lower the factor of safety, increase the length or the width. Or, figure out another. Or as you can see, these SSD tables are super powerful. So what else can I do with this SSD table? Now, one of the things I like the most about them is I can actually come in and add another structure. Can you even believe that? What would I need a third outflow for? Well, maybe you want to try to use this as like a flow splitter. For example, I have a manhole with one pipe here, and maybe this pipe goes one way, this pipe goes another way to some facility. This one goes to a stream. You can actually do that sort of thing with SSD tables. Now, one other thing I should show you is it's really important to make sure that you connect these in the correct way. So if I connect this element to that one, you can see 1, 2, 3. That's 1, that's 2, that's 3. So this is the infiltration one, and then this is the outlet. So for example, say I turn this one off, and I do have a pond downstream of infiltration trench, and I connect this to 1. I don't really want to connect outlet 2 because that outlet 2 is going into the ground. So it shouldn't go to my pond. If I connect outlet 1 to there, likewise, if I'm deciding I want to do a point of compliance, I probably only want to connect outlet 1 because point of compliances are usually figured out how much water is going to a stream or to a discharge point. Now, if you're infiltrating water, that water should not be going to your discharge point. So that's one thing to really look for with these SSD tables when you are trying to figure out if you're meeting minimum requirements. Okay, I hope this wrapped it up for you. SSD tables are super powerful, but also really frustrating. I hope this tutorial video helped you figure out how to use them. Until next time.
Hey, thanks for watching. Let me know what you think in the comments below. Do you like SSD tables? Do you use them? Do they frustrate you? Hey, thanks for watching and have a great day.